So in this lecture, let us see how to resolve forces which will be required in many situations. Especially this resolution of forces will be much useful in analyzing trusses. So in trusses we'll be having inclined forces due to wind acting on a truss. So if we have wind load, then wind load, inclined load must be resolved along horizontal axis as well along the vertical axis. So resolution of forces is an important aspect before analyzing a truss. So let us see some examples how to resolve a force. Say let us have an inclined force 50 Newton acting at an angle of 60 degree with respect to x-axis as shown in the diagram. So this inclined force need to be resolved along x-axis and along y-axis. So for easy remembrance, let us have one aspect, that is, whenever we want to resolve a force along horizontal axis, say this is x-axis horizontal, or along the axis where the angle is contained, you can remember like this. So whenever we want to resolve a force along the horizontal axis or along the axis about which the angle is contained, then that component will be in terms of cos theta. Always we can have like this, provided the force should have inclination with respect to horizontal axis. If we have the inclination with respect to horizontal axis, always we can blindly calculate the horizontal component as cos theta and vertical component as sin theta. One more thing is to be, or one main thing to be noted is, angle should be with respect to the horizontal axis. If it is with respect to the vertical axis, then convert the angle with respect to horizontal axis and then use this concept. So we have 50 Newton acting like this. So if you resolve along x-axis, you'll be getting 50 cos 60 cos theta, because along the horizontal axis cos theta, therefore cos 60. And if it's resolved along the vertical axis, 50 sin 60. Another important thing is, after resolving, where will the force be pointed towards? So if you see here, for that, what's the direction of the arrowhead? So when we resolve horizontally, where will the arrowhead go? So whether it will go towards right or towards left. So if you see here, the arrowhead is pointing this way upward. So if I resolve along horizontal axis, it will come like this. Therefore, the arrow will be moving towards right. So with respect to horizontal component, towards right is positive and towards left is negative. Similarly, when we resolve vertically, we should observe the direction of the arrowhead. So if it is resolved vertically, this arrowhead will be pointed upward or it will move upward. So after resolving vertically, when it moves upward, then it is positive. After resolving vertically, when the arrowhead points downward, then it should be negative. So these are the sign conventions which we'll be using throughout the resolution of forces as well in the analysis of trusses. So it should be remembered that any inclined force which is having angle with respect to horizontal axis, the resolution of the component along horizontal axis is in terms of cos theta, and the component in terms of vertical axis in terms of sin theta. This should be remembered, provided theta should be with respect to the horizontal axis. Even if it is not with respect to the horizontal axis, have the angle with respect to horizontal axis and do this process. So coming over to the next example, say here, we have an inclined force of 60 Newton acting at an angle of 40 degree here. So we want the horizontal component as well the vertical component. So if I resolve it horizontally, then 60 cos 40. 60 cos 40. This is very clear because with respect to horizontal always cos theta, and with respect to vertical it will be sin theta. Therefore horizontal component will be 60 cos 40 and vertical component will be 60 sin 40, because already we have the angle with respect to the horizontal axis only. Therefore 60 sin 40 is this and 60 cos 40 is this, and we should observe the direction of the arrowhead after resolving. So after resolving horizontally, the arrowhead will be pointed towards left. Similarly here, after resolving vertically, the arrowhead will be pointed upward. Okay. So with respect to horizontal component, since it moves towards left, minus sign, and after resolving vertically, the arrowhead moves upward, therefore plus sign need to be used. So coming to this example, say we have a force of 10 Newton, the arrowhead is pointing towards this origin like this. So it is like this, it is acting towards the origin like this. So we have vertical component, we have horizontal component. Horizontal component will be always in terms of cos theta, vertical component in terms of sin theta. provided theta should be with respect to the horizontal axis. That is more important. So after resolving, where will the force move? That will decide the direction of the component. So if I resolve horizontally, the arrowhead will move towards left like this. Say if it simply bring this force here, what will happen? So the arrowhead move, what's the direction of the arrowhead? So it will move towards left, therefore minus. And if I resolve it vertically, the arrowhead will be pointed upward. So it will be plus 10 sine 30. Okay. So similarly, if we are given a force like this, say 20 Newton acting at an angle of 50 degree with respect to vertical axis. So as we told earlier, whatever may be the angle, first express the angle with respect to horizontal axis. So though it is 50 degree, so with respect to horizontal axis, it will be 90 minus 50 will be 40 degrees. So 40 degrees is the angle made by this inclined force with respect to horizontal axis. Then as usual, you can say horizontal component will be in terms of cos theta, that is 40. And this will be in terms of sine theta, therefore sine 40. And after resolving, where will the arrowhead be pointed? So after resolving horizontally, the arrowhead will move towards left here, therefore minus. And after resolving vertically, the arrowhead will be pointed downward, therefore minus for vertical component also. So this procedure we are going to use for the analysis of trusses. So let us have another example wherein we have several concurrent forces, that is forces acting at a single point. So let us start resolving. So before starting resolving, please identify the angles, whether the angles are of the forces are with respect to the horizontal axis. Say if you take this 20 Newton force, where the angle with respect to horizontal axis is given, and with respect to this 8 Newton force, angle with respect to horizontal axis is given. And this is vertical force, and this is truly horizontal force, and this is an inclined force. For this 50 Newton, the angle is given with respect to vertical axis. So before proceeding, finding the components, convert all the angles with respect to horizontal axis. So this is 25 degree, leave as such, 30 degree, leave as such. Here 55 is here, therefore 90 minus 55 will be 35 degree will be the angle made by this 50 Newton with respect to horizontal axis. And already we have horizontal force here, we have vertical force here. Now let us start the resolution of summation of the horizontal components, that is sigma h, sum of all horizontal forces. Let us start with the already available horizontal force. So already available horizontal force is 50 Newton and it is pointed towards right, therefore plus. Here we should write the sign convention. We are going to treat towards right as positive. That means towards left will be naturally negative. Therefore this is plus 15. Then come to this force. This force can be resolved horizontally. So 15 cos 35, and when it is resolved horizontally, it will be pointed towards right, therefore plus 15 cos 35. Then come to this 10 Newton force, as it is truly vertical, it will not have horizontal component, therefore that will go here 20 Newton. 20 Newton can be resolved horizontally, therefore 20 cos 25 degrees. And when it is resolved, the arrowhead will move towards right, therefore plus. Then coming to this 8 Newton force, 8 when it is resolved horizontally, it will be 8 cos 30, 8 cos 30, and then the arrowhead will be pointed towards right after resolving. So after resolving, it will be pointed towards right, therefore plus. So when we add all these things, we'll be getting the sum of all horizontal forces. Then coming to sum of vertical forces, so let us start from here. This 50 Newton, this is horizontal, therefore it will not have vertical component. Come to here, 15 Newton, vertical component of 15 will be 15 sine 35. Therefore 15 sine 35 is written here, and watch the direction of the arrowhead. So after resolving, it will move upward, therefore plus. Then we have a 10 Newton force, which is truly vertical, therefore simply add this 10 Newton, and the arrowhead is pointed upward, therefore plus 10. And coming to this force, if it is resolved vertically, 20 sine 25, 20 sine 25 is here, and when it is resolved vertically, the arrowhead will be pointing towards downward direction, therefore minus 20 sine 25. And coming to this inclined force, this 8 when resolved vertically, 8 sine 30, 8 sine 30, and the arrowhead will be pointing upward, therefore plus. Therefore this will be sigma V. So this is how we should find the sum of all horizontal forces and sum of vertical forces. And if we want to find the resultant of the system of forces, then resultant is given by root of sigma h squared plus sigma v squared. We can also find the direction of the resultant using tan theta formula. Therefore, plot the h and v and then find the angle made by the resultant. So this principle has to be remembered or known thoroughly. We should have full understanding before going to the analysis of trusses. Thank you, viewers. Thank you for subscribing our channel and making it reach everyone. Thank you.